7.6 is some applications, code for word problems. They're not all word problems, but there are a few of them. Problems 1 and 2, and I don't think we need to do both of these, but these are just proportions because we have already reviewed solving proportions. So let's take a look at problem number 2. We will skip number 1 and let's look at problem number 2. I have x plus 2 over 2x plus 5 is equal to 3 over 5. Now, there is a variable in the denominator, which means we should be concerned about domain, and I'm actually thinking about it right now. The reason I want to emphasize it in this problem is in our earlier problems, it was really easy. It said something like a plus 6, and you said, well, don't let a be negative 6. Or it might say a minus 3, and you said, don't let a be 3. Well, this one, some of you could do it in your head, others maybe not. So when you talk about the domain of this one, you have to use that process we did in 7.1, which was take 2x plus 5 equals 0. Solve it, subtract 5, 2x is negative 5, which means x dividing by 2, x is, let me write that a little neater, negative 5 over 2. But that's actually the domain restriction. We're not going to let x equal negative 5 over 2. So if it turns out to be negative 5 over 2, I have to throw it away. And that should be a good review for the first topic from 7.1. All right, back to my problem. It's a proportion. How do I solve proportions? Cross products. This product equals this product. Doesn't matter which side you put which one. One of them is going to be 3 times 2x plus 5 equals, the other one is going to be 5 times x plus 2. That gives me 6x plus 15 is equal to 5x plus 10. To solve that equation, I choose to subtract 5x from both sides, and I get x plus 15 is 10. Subtract 15, and I get x is negative 5. And is that a problem as far as domain is concerned? No. That's a good answer. So you will start this lesson by doing 2 proportions. And I've done one of the 2. All right. Problem number 3. It's a little bit distorted because to make it larger, I could only make it larger in a vertical sense, so we get tall, skinny letters, sort of. It says, the ratio of the weight of an object on planet A to the weight of an object, the same object, on planet B is 100 to 3. That's the ratio, and the order is given. The 100 represents A, and the 3 represents B, because that's the order that it was said in the sentence, A to B. Then it goes on, and a little piece of it got chopped off. If an elephant weighs 3,400 pounds on planet A, find the elephant's weight on planet B. This is a typical proportion question. There's a comparison, and then there's an incomplete comparison. All right, the first comparison, it is 100 is to 3. And something you need to be well aware of is the label. 100 is a weight on planet A, and 3 would be the same thing getting weight on planet B. So it is A to B. That means that when you set up the other ratio, it is in stone that the numerator must be A and the denominator must be B. So it goes on to say, if an elephant weighs 3,400 pounds on planet A, where does 3,400 pounds have to go? Top. Those of you who happen to have taken Math 301, you did proportion questions like this. We don't know the weight on planet B, that's the question, so that will be variable X. What kind of equation is this? It's a proportion. The domain restriction, I'm not going to write it down, but would you agree that X should not be 0? And do you believe that the elephant will weigh 0? No, it's not going to be a problem. All right, so I need to look at my cross products. One of the cross products is 100x. The other cross product is whatever 3 times 3,400 is. So I have 100x is 0, 0, 12, 10,200. Divide by 100. Divide by 100. X is equal to 102. So on planet B, the elephant steps on the scales and only weighs 102 pounds. I would like to visit planet B. Okay, did the elephant change his mass? No, the gravitational pull was different on that planet. Okay, so it was a proportion question. Problem number 4. I think this one will set up, but we may not take our time to do the work. Once again, there's a little distortion as you try to read it. It says, there are 110 calories per 28.4 grams of cereal. I hear that as a comparison. 110 calories, I'll put a C for calories, compared to 28.4, and that's grams of cereal. So calories to cereal is the way I'm setting this up. Equals. Find out how many calories, well to me it sounds like they just told me to put an X in the numerator, because that's calories, are in 48.28 grams of cereal. Would anybody have a problem solving that? You would look at this cross product and you would look at this cross product. And I can give you the answer. I think it's a decimal answer. Maybe not. Oh, no, it's not a decimal answer. If you were to work this out, you would get 187. But I'm not going to take our time to do that. Let's go to 5. Now, I probably should have blown this one up. It says, find the unknown length y, which is right here, in the pair of similar triangles. Now, if you took Math 301, and I keep mentioning that because we did a lot of things with proportions in there, then you're familiar with the concept of similar. Similar triangles have proportional sides. So, there's more than one way to do this, but I do corresponding parts. I say 5 feet is to y as 16 feet is, 16 feet is to 10 feet. That's not the only way that it can be set up. But having taught geometry back in the olden days, long time ago, I remember that it was important for people to recognize what corresponded to what matching part. So I encourage my students to set it up this way. You could set it up 5 is to 16 as y is to 10, and you'll get the same answer. All right, cross products. I'm going to have y times 16 is usually called 16y, and 5 times 10 is 50. Divide by 16, and y is equal to. Now, in this problem, and this is the first one that I recall this happening, the instructions say, and I didn't copy them onto this, but it says, simplify your answer. Type an integer. That means if it goes in there a whole number of times, put the whole number. A proper fraction. A proper fraction has a top smaller than the bottom, like 2/3, 1/5, or a mixed number. Now, you hardly ever answer things in MATLAB with mixed numbers, but you do sometimes in MATLAB this time. So, as a mixed number, 16 does not go into 50 evenly. It goes in there 3 times, which gives me 48. I have 2 left over. It is 3 and 2/16, but that reduces to 3 and 1/8. It is quite unusual, from my recollection, for MATLAB to want a mixed number answer, but it does. Remember, the toolbar has this symbol, and that's the symbol you're going to need to put in a mixed number. So watch the instructions.
So the mixed number you divide?
Yes. You divide, the remainder sits over your divisor, and then you reduce it if you can. And I did. 2/16 turned into 1/8. Is that okay? Okay. Now, finally, we're going to get the new kind of word problem, and I'll read it to you. Those of you at the back of this room, I know you can't read that. Maybe if you're up front, you can't read that. This is called a work problem. Now, I want to write something up at the top. I want to write my pattern for solving work problems. This is not the same pattern that the author of your book uses. If you say, show me an example, if you watch the videos or read the textbook, videos, I mean their videos, it will not be explained the same way I'm going to. So fair warning, I don't mind you using her approach, but it will be different. My approach is this. In all work problems, you have either 2 or 3 or a whole bunch of people or machines trying to do a job. That's why I call it a work problem. They're trying to get some work done. Each person or machine does part of the work. And together they complete a job. So what I'm going to say is for each person or machine working, you're going to create a fraction. I'm going to show my example with just 2. And they're going to work together to complete the job. So my strategy is always going to be a fraction for each thing that's working. Together they add up to 1, a whole job completed. Now the fractions. The denominator of the fraction will be the alone time. In other words, if somebody said, oh, I can do that job in 5 hours, then that person's denominator will be 5. And somebody else says, well, I can do it in 3 hours, then that person's denominator is 3. It's their alone time. The numerator is the time that they work when they're together. So I'm just going to write together. The together time is on top and the alone time is on bottom. You better be able to get the job faster working as a team than you could individually, or it's a really, really bad team. We're going to assume that these are good teams. Okay? Is everybody kind of okay with my strategy? That's how I'm going to set all mine up. All right, now let me read this to you because it is a little distorted. It says, Smith Engineering is in the process of reviewing salaries for their surveyors. During the review, the company found that an experienced surveyor can survey a road in, and this is very squished, that is the number 7 hours. It goes on to say an apprentice surveyor, that's a different guy, needs 9 hours to survey the same stretch of road. If the two work together, find out how long it takes them to complete the job. All right, this time I'm going to set each and every one of these up. How many things, people in this case, are working? 2. So fraction number 1 plus fraction number 2 equals a whole job getting done. The first fraction I'll let be the first person they talked about. It's the experienced surveyor. And how long does it take him or her to do the job alone? 7 hours. So that denominator is 7. The apprentice needs 9 hours to do it alone. So that one's denominator is 9. What goes on top? Together time. Do you know their together time? No, that's the question. So X is on top because the together time is unknown X. Is that okay? I have an equation with fractions in it. In lesson 7.6, I'm sorry, this is 7.6. In 7.5, I discussed how to solve that. Multiply by the LCD. What's the LCD of these denominators? 63. So here I go. 63 times x over 7 plus 63 times x over 9 equals 63 times 1. I have 3 little products. 7 goes into 63 9 times. That gives me 9x plus 9 goes into 63 7 times, and 7 times x is 7x, and that equals 63. What's 9x plus 7x? It's 16x is 63. Divide by 16, and x is equal to, and before I complete, I go back to the original problem to see what the answer says, what the little instructions, and it says, type as an integer, well it's not going to be an integer, it doesn't go in evenly, or a simplified fraction. It does not say anything about mixed number. So 63 over 16 is simplified. It is reduced to lowest terms. It's done. No mixed number on this one. But what's important, and will stay important, is this pattern. Together on top, alone on bottom. Let's do a couple of other work problems. It says, in 4 minutes, a conveyor belt moves 500 pounds of recyclable aluminum from delivery truck to storage area. Well, there was actually only one thing in that whole sentence that was important. 4 minutes. A smaller belt moves the same quantity of cans, the same distance in 7 minutes. Are those numbers alone times or together times? Alone times. It goes on to say, if both belts are used, find out how long it takes to move the cans to the storage area. If both belts are used, which will be together, and that will be X. So here we go. We have belt 1, belt 2 equals 1. Belt number 1's alone time is 4 minutes. Belt number 2's alone time is 7 minutes. And what's their together time? X. Will y'all allow us to be a little bit lazy on this one? What's the LCD? 28. I'm going to sneak in a red 28 there, there, and there. That allows me to not have to write the whole problem over. I have 1, 2, 3 products. 4 goes into 28 7 times. I have 7x. 7 goes into 28 4 times. I have plus 4x is equal to 1 times 28 is 28. Combining my like terms, I have 11x is 28. I'm going to divide by 11. X is, pause, go back and read, and it changes. Number 7 says, simplify your answer. Type as an integer, nope. A proper fraction, nope. Or a mixed number. It does not, this one says mixed number. So to get a mixed number, I divide 11 into 28. Maybe you do it in your head. It's going to go in there 2 times for 22 with a remainder of 6 11ths. My answer is 2 6/11 minutes. I wish it were consistent. Maybe it's a reading thing. Yes, sir.
So now it's number 6.
Uh-huh.
The answer is different than what we have. On the math lab, it's 3 and 15/16 for the answer.
Really?
Yeah, on the math lab it is.
Okay, then my apologies. I'm going by what it gave in the instructions, and it just said an integer or simplified fraction. If you change this to a mixed number, and we say 3 times 16, and I didn't even look up the answer, but thank you. That gives us 48, and we have 15 left over. 3 15/16 is what it wants, but it didn't tell me, because I'm sitting here reading it, it did not tell me it wanted that mixed number. But you are totally correct, and I'm glad you said something. So, even though it didn't say it wanted a mixed number, I was wondering about the inconsistency. It's evidently inconsistency in the instructions. So, sorry, but thank you for that. All right, so we did 7. Let's look at 8, and once again, there was, even when I tried to make this big, it was just hard to read, so I will read it out loud to you. It says, Marcus and Tony work for Lombardo's Pipe and Concrete. Mr. Lombardo is preparing an estimate for a customer. He knows that Marcus lays a slab of concrete in 9 hours. Marcus, 9 hours. Tony lays the same size slab in 3 hours. If both work on the job and the cost of labor is $40 per hour, decide what the labor estimate should be. Okay, now there's a little extra in this question. First, I'm going to need to figure out how many hours they're going to work so that then I can figure out the cost. So, there's Marcus, there's Tony, and they get a job done. What is Marcus's denominator? It is 9. And Tony's denominator is 3. How long will it take them if they work together? Well, that's exactly what I need to know. So that will be X. If we're a little bit on the lazy side, and I multiply by the least common denominator, which is 27, I get 9 goes into 27 3 times, so I have 3x plus 3 goes into 27 9 times, 9x is equal to 27. So 12x is 27. Divide by 12. X is equal to, I'm going to, I can simplify this. What will go into both 27 and 12? 3. So if I divide each of these by 3, I get 9/4. Now, I don't have to change that to a mixed number because that's not what the question is. So I'm going to leave it improper. The question is, what's it going to cost? What should the estimate be? Well, how much does it cost for each hour? $40. So it is $40 times 9/4 hours. Does that work out okay? 4 goes in there once, 4 goes in there 10 times, multiply. It is $90. The question did not say how long will it take them. It says if both work on the job. So that's the together part. And the cost of labor is $40 per hour. Find out what the estimate should be. So there was something extra in this question. Okay. I have no idea. It is 9. Did 27 work out okay? Okay. Now, she pointed out a great thing, and nobody else said anything. I think my other class did the same thing. Somebody said the least common denominator is 27. I took it. I went with it. It worked. But did we have to reduce our answer? If we had used your 9, we would not have had to reduce the answer. The least common denominator in this problem is 9. And so I just heard something. I went with it. It worked for me. You are so totally correct. 9 is the least common denominator. The bigger ones will work. They just cause you to reduce at the end of your problem. Okay, so I'm glad you pointed it out. And I'm sorry if you were sitting there going, did she just change the rules on finding common denominators?
I have another question.
Yes, ma'am.
Are they always going to be addition?
Okay, our problems are always going to be addition. But what if you had 2 hoses filling up a swimming pool, but somebody forgot to plug it in? So you have 1 hole that's draining it. In that case, you have 2 things working toward a goal of filling and 1 thing working against. You would have subtraction. So you can have something working against you. We're not going to encounter that. Okay? All right, number 9. And speaking of pipes filling things up, we just don't have anything draining here. Problem number 9. It says 1 pipe fills a storage pool in, and it's very hard to read the way this does it sometimes, 8 hours. A second pipe fills the same pool in, and this one's even harder to read, it is 4 hours. When a third pipe is added and all 3 are used, okay, that means together, doesn't it? The pipe to fill the pool, it takes only 2 hours. Find how long it takes the third pipe to do the job. This is different. Several things are different. First of all, do y'all agree there are 3 fractions? We've got 3 pipes working. Let's look at their alone times. The first pipe, its alone time to complete the job is 8. Second pipe can do the job in 4 hours. When a third pipe is added and all 3 are used, that's together, it takes 2 hours. 2 hours is together time. We've never had that before. How long will it take the third pipe to do the job? That's my question. That's pipe number 3's alone time.
If it tests together, they're going to be the same number on both.
Yes. Okay, so usually together, well, in ours for sure, the together time is always the same. I have seen word problems where it would say, pipe 1 worked for 2 hours by itself, and then they did something else. And we're not going to encounter that. All right. You could reduce these, but most people wouldn't even think about doing that, so let's just go ahead and jump in. What will the common denominator be? 8x this time. I will not jump in there and use 32x. It is 8x. So if we're a little bit lazy and we use 8x, 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 and don't forget the right-hand side, 8x. In the first fraction, the 8's divide out, and I'm left with 2x. In the second fraction, 4 goes into 8 2 times. I have 2 times x times 2, which gives me plus 4x plus, what happens in this third fraction? The x's divide out, and I'm left with the number 16, and that's equal to 8x. On the left, I'm going to add 2x and 4x for 6x, plus 16 is 8x. Subtract 6x from both sides, at least that's my choice. 16 is equal to 2x. Divide by 2, 8 is equal to x. So what is it we just found? The third pipe's alone time to get the job done. Is that okay? All right, let's look at the last one. And I'd like for us to set it up, and we're not going to take time to solve it, though. All right. And I'll read and highlight the things you need to know. It says, in 8 hours, I might need that, an experienced cook prepares enough pies to supply a local restaurant's daily order. Okay, one cook can do it in 8 hours. Another cook prepares the same number of pies in 9 hours. Together with a third cook, they prepare the pies in, and it's squished, but it's 8 hours. No, it's 3 hours. That's a 3. You can't see that 3 on the screen. Okay, that's a 3. Find how long it takes the third cook to prepare the pies alone. Third cook alone is x. How many fractions do I have? 3. Cook 1, cook 2, cook 3. Cook number 1 can do the job in 8 hours. His denominator is 8. Cook number 2 can do it in 9 hours. His denominator is 9. Cook number 3 can do the job in X hours. So I don't know. How long do they work? Together, 3 hours, so they all get a numerator of 3. If I were to finish this problem, what would the common denominator be? 72x. And we're just going to say, voila, x is, and it wants a mixed number, and we would get 10 and 2/7. It appears that all improper fractions get turned into mixed numbers in this lesson. Although not all the instructions tell you to do that. Are y'all okay on work problems? Together on top, alone on bottom, always added up equal to 1. The only time you could possibly not get a 1 over here, although you are always going to have a 1, if you had a problem that gave you numbers on filling a tank all the way, but your instructions said for some reason you were only going to fill it 3/4 full, then it would add up to be 3/4 of the job. That's not going to happen to you. Okay, word problems are done.